Okay.
Hi, hello everyone. Welcome to the third workshop of aelf Hackathon. This is Ian, and the R&D director, and I'm Matt,
It's me
the,
again.
the marketing manager. So I hope that all of you had an amazing Christmas, and I'm going to share a piece of good news to you that there are already eight participants joined the hackathon until now, and seven of them already submitted the project. And by the way, for those who join or who want to join the hackathon, please join our developers group on the Telegram. And the link will be sent into the chat box during the session. And into this session, there are several main aspects. And now Ian will start the session today, and feel free to ask any question. I will answer you before the end of the workshop. Thank you.
Okay, guys, it's me again. So last time I gave a quick review about how to use LCI tool to generate an aelf contract project, and at the same time, a more complicated demo was shown during that workshop. And at the end of the last workshop, I was about to introduce to the system contracts of aelf Midnight, though I can't tell you more about that because of the workshop time limit. But actually, never mind that, because in this workshop, I will show you exactly how to use these system contracts to build your own apps. And basically, these four system contracts will be introduced today, and I will show you some of the code. And especially for those who curious about how to publish their own tokens in the aelf Midnight. Of course, you can choose to implement some method similar to ERC20, and we translate this method to a proto file, call it ACS20, and the ACS stands for aelf Contract Standards, or you can say aelf Contract Specs. And I can show you this profile, transfer from above, approve, sorry, and some view methods, name, symbol, decimals, total supply, balance of, and their loans. And if you choose to publish a token in this way, you have to implement your own token contract and manage to deploy the contract to the aelf Midnight. But as you may know from the other news articles, aelf blockchain was designed as a structure that we have one main chain and connecting to other side chains. And tokens or asserts can be easily transferred from one chain to another, and as long as they are created in the system token contract. We have these two methods. So if you just deploy an F20 contract to one of an F sidechain and want to do the cross-chain transfer in the future, the only way to transfer your token from one sidechain to another sidechain or the main chain is to use the Oracle mechanism, or you may call it cross-chain bridge or something. And meanwhile, if you use a system token contract in aelf Midnight, you don't even need to write your own contract. Just call the create. Just call the create method, then you create an asset that can be transferred all across the aelf Midnight using cross-chain transfer and cross-chain receive token. So let's launch a cross-chain transfer now. And this is our web wallet log here. So this is my account, and I want to transfer one. Sorry, this is my mail address. This is my main chain address, and this is my side chain address. To more to be more clear, it is the side chain called TDVV. I'll just copy this address. Watch out this and value. Before that, you may check the notes of question transfer. You just modify your address to this format. Yeah. Send. Okay. It maybe should wait a while. I'll show the code soon. Because the creation and transfer tokens mostly happened by sending transactions offline. So this time I'm gonna to use a unit test to show the usage of some methods. The methods are listed here. Yeah, the methods. Um, okay, talk is cheap, and I prepared to do a lot of code today. So we'll start from the FCI. Use a new command. Yeah, new command and aelf contracts. So this time I'll call it workshop 2. Actually, this is the third workshop. Yeah. Sorry. Three contract. Double click the parent file. Okay. We'll go to the unit test project directly. And wait a moment. Okay, just ignore this to make a new multi-token test. And don't forget to reference the token contract as a stop here. A reference to the contract stop in the sales project fair. Rebuild. Next we need a similar method like this. Just turn container. Sorry, container. Stop. Okay. Token contract address are rarely signed in the D app contract space. So just so I can directly use its value. So for testing the MultiToken contract, first of all, I need a stop. I choose a key pair. And sometimes I want to use the address of this account, so I just point. Account dot pair. Then I get a stop, and next I will use this stop to create a token. Oh, sorry, I forgot to change the name. A token stub is created. Yeah, call the create method directly, and like you pretending you are send a create transaction offline to the aelf blockchain, and we the create input. So the symbol, the symbol of the token gonna create, and we'll call it Ian, which is my English name. And issuer should be the address of this account. Decimal, the decimals of F is 8. I will copy that. And if vulnerable is true, it means everyone can burn this token on his own, and the token name will be token. Total supply, I can make it billing. It's 1 billion, right? 1 billion. And yeah, that's all. Maybe that's all for now. And after the creation, I will check whether this token is already created successfully, and we'll reuse this step to call the get token info method, pass a symbol in, and then check the issue. It's okay. Issue should be account dot address. Yeah. If the issue is correct, then the token info should be, at least it is created successfully. And we will use debug to run this test case. What's this? Okay, the token info is same as I just filled before. Decimals is born, issue, symbol, and token name. Yeah. So one more addition comment: the token contractor is already deployed and initialized if you use a test unit test project directly. Yeah, you can use that as soon as you prepared this project. So I just tested the create method. Next, I will show the issue. And maybe this time I want to rename this account as the issue account, because this is the issue start, because I maybe use other spenders or other normal users to transfer this token, the yin token. I just create some of them, like the user account, skip one. If I test the transfer form or the approve method, I must use a spender. Skip two. Okay, and the stops. User stop. User account prepare. And the spend stop. reorg this file. So this time I still use issue stub to issue some tokens. Just call the issue method here. So I will issue tokens to the user account.address. The amount is 100 and the symbol is BAN. And then I can check the balance of this account. And we can use a get balance method. Balance issue. I will just use the issue stop. Issue stop. Issue stop. Get balance. Use coins. Okay. The owner is this address and the symbol is in. So the balance should be 100. Let's try whether the issue transaction can work. Issue get balance. Yeah, it's success. Means the balance of this account is already 100. Transfer. I will use the user stuff to do the transfer because he already has the 100 yen tokens. So let me quit the Telegram. Transfer to the issue account because we can't really have this account to get the token and the symbol in amount transfer 1. And after this transfer has done, we want to know the balance of the issue account. It should be 1. Copy this code. I want to reuse the variable name and it's this time I want to check issue account. Should be 1 or and the account the user should be 99. Okay. And check what we should do next. Transfer approve. Yeah, next we'll do approve. The approve method is defined in ERC20 and it's allow the someone to transfer tokens from another's account into a third party. So this time I will use a user account to approve some token for the spender account. Do this user account user stop. Sorry, user stop. Approve. Fill the parameters like the spender is spender account address. Symbol is amount is 100. Yeah. Then we will check the amounts. Yes, okay. Loans. You say, okay. Because this is a view method, it doesn't matter. Which is a sender account. A get belongs. The owner is the user account. Standard account. So the long so should be 100 as I said before. Yeah. So the last one is transfer from. I will use a spend account to transfer some tokens from the user account to the issue account or himself. Transfer from. And stop. From addresses user account to I will transfer to a spend account himself. Just easy to check the balance. I don't need to do the calculation. The amount is 10. So this time the balance of the spender should be 10. The balance of the spender account should be 10. Yeah. Let's do this. So I've showed you some basic, or you can say all the basic methods in the multi-token contract. And remember one thing, it's time for me to receive my F token from the sidechain. I have a unconfirmed cross-chain transfer. It's from my main account to my sidechain account. And after I do this, yeah, actually I will set a cross receive method. It should be called cross-chain transfer to a cross-chain receive token. Okay. Transaction ID. Go to the aelf skin to check this one. Okay, sorry. I need to go to the sidechain skin to check. Yeah, it is already mined. And actually, the cross-chain transfer transaction was done by some transaction of cross-chain. Cross-chain contract. Cross-chain. Yeah, here. And this is a cross-chain transaction, a cross-chain contract of the sidechain, and I'll open a new one. Yeah, and this is a cross-chain contract of the main chain. And as you can see from here, the main chain and the sidechains are keeping indexing from each other by these transactions, proposal and release. So the interval is like 1 minute. So the principle of the question transfer itself is to show the existence of one transaction in another chain by constructing a Merkle proof. And there's a parameter called Merkle path in the question receive token transaction. And the question transfer transaction is exactly the data to generate. This is a transaction region paths, and this is a data to generate the Merkle tree node. Okay, so enough about the multi-token contract. Let's go to the much simpler contract. It is vote. If you want to launch a vote item using blockchain, you can use this contract. And same as before, I'll just show you the pipeline of using the vote contractor to holding a voting item. Yeah, vote contract. Oh yeah, it's okay. Perfect. Let's assume that we want a group of people to decide the title of a hackathon, yeah, the hackathon title using voter contract, and they want to the group of members to use the yen token I just created to do the voting, which means I have to transfer the yen tokens to them to give their permission to vote for the title. And this time I will follow these steps to create a voting item and vote and take snapshots. And after that, the voters can withdraw their tokens. And finally, we'll get the voting results, which is just to show the snapshot we taken before. And obviously, I want to use a yen token, and I need someone to really own this token, so I will just token stop. I will return the user stop here, and I can call it token stop because it owns some yen tokens. Yeah. And we want a account to create or register, create a voting item. We always use a sample count dot accounts to fabric some accounts in the unit test projects. Let's do the first in the voters vote accounts. I don't know whether the answer should be added. Anyway, this is in code, not the article. I'll skip the first one, then pick and skip the skip the first five to take the next five accounts. Better to make it to list. I should have, oh yeah, sorry. I forgot to reference vote. Contract stop. Rebuild. Oh. Okay. It's built.